Okay, this video is going to be a little bit shorter because the only thing we're going to cover is a problem that we have with this schematic and how we're going to deal with it. Now the video coming after this is going to take me a little bit longer to film because it's going to deal with the diodes and rectifiers. But before we do that, we've already learned how to take our mains voltage and convert it into other voltages that we need for our circuit. And of course those voltages are still AC, so they're alternating. And the next video will deal with changing that alternating current to direct current and how we'll use diodes to do that. And we'll do a little primer on how diodes work. But for this video, we have a problem. Our filaments, as you can see, are AC and they don't need to be converted into DC. And when we talk about vacuum tubes later on in the series, we'll find out why it's not a big deal. But the problem is when you look at the schematic that comes with this little kit, and this happens quite often, they do show you the pinout of each tube for the different elements, but what it does not show you is the pinout for the filaments. It shows you that the filaments attach to this set of windings, but nowhere does it say which pins, for instance the 6P1 output tubes or the 6F2 driver tubes, preamp tubes, which pins you connect the filaments to. Now we can do a little bit of process of elimination by seeing that we have pins 1, 2, 3, and 6, 7, 8, and 9. So the only two that are left on this one, this is a 9-pin tube, are pins 4 and 5. So that's one way we can determine where the filament connections are if we don't have that information on the schematic. So perhaps these are going to be pins 4 and 5, but we'll verify that. Now when you deal with these output tubes, you only have pins 1, 2, 3, and 7. All the other pins, we don't know what they are, and we're going to have to find out. So we don't really know which two pins are filaments. So how are we going to do that? Well, let's look at the first way. What happens if we do not have a data sheet? Okay, we're going to look at a data sheet later on, and then we're going to connect these filament wires. But what if we don't have a schematic, but all we have is the tube? Well, the first thing we need to do is learn to identify what a filament looks like in a tube. So let's see if I can get zoomed in close enough that we can actually see that. All right, the first tube we're going to look at is the 6F2 tube. And the 6F2 actually has two tubes in one envelope. So you can see this larger portion here, and that's a pentode tube. We'll talk about pentodes later. And then this narrower one here on this end, that's a triode. So there's actually two tube elements, or two separate tubes in this one glass envelope. And they share the same filament connections. So you only have one connection for the filaments that use up 2 pins. So what does a filament look like? Well, a filament looks a little bit like a light bulb filament. Let me get one of those. So here's just your average light bulb, and it is essentially a vacuum tube that only has one element, and that is the filament. And you can see that thing running right down the middle. This part right here in the middle, that's your filament. And all it does is get hot when you apply voltage to it. When current passes through it, it converts that current into heat, and that heat also gives off light. So you have two different forms of energy there. And another thing that it does is it creates the free electron cloud that you need if you have the other elements in there for the vacuum tube to work. So this is what we need to have power connected to on our tube. So we're looking for something similar to this, but what you'll find is in a vacuum tube, this doesn't matter if there's any electron cloud or anything around the filament. But we want to promote that on a 3-element tube or a 2-element tube, because we really want those electrons to be able to migrate from the cathode to the anode. So they will often coat it with a white powder coating, and I don't remember the composition of it, and I'm not going to say it if I'm not sure what it is, but I'll put it up on a note here in the video. And so we're looking for a little spiral filament like this connected to 2 pins. And if we look at the tube here, see down in there, right here, see that little V-shaped thing? And see how it's white? That's your filament for the one tube that's in there. And if we flip it around to the other side, you can see here is the other filament. See that little V shape? And they're both wired together to the same pins, and if you follow those pins, so here's these 2 little ends here, and those go back to here, and you can see they're connected. I don't know if you could see it, but they're connected to this pin and this pin. And if we go through and we count, you look from the bottom, you count clockwise, pin 1, 2, 3, and these are the 2 pins, pins 4 and 5. So just like we determined from looking at the schematic and kind of using process of elimination, pins 4 and 5 are our filaments. Now normally, the first number in a vacuum tube's model number indicates what filament voltage it has. So this is a 6F2, so it will have a 6 volt or 6.3 volt filament. And also this is a 6P1, so therefore it will have a 6 volt filament once again. And filaments don't have exactly 6 volts. They're actually 6.3 volts. That's just a standard. So now we know that we need to connect to pins. So we could draw our little filament in there, right? And this will be pin 4 and pin 5. And then all we have to do is figure out what pins this has. So we're going to use the same process here and see if we can figure this one out. Okay, here is our other one. It's hard for me to see this through the camera, but right down there in the middle, once again, you can see the little white filament leads going down into the middle of the tube. And they go on to these 2 pins right here and here. You see that? And again, that will be this pin and this pin. So if we flip it around, these 2 pins, again, it is pins 1, 2, 3, pins 4 and 5. So 4 and 5 on this one are also the filaments. So let's write that down on here. Pin 4 and 5. So that's all we need to know. Now, let's see if we can dig up a data sheet for these tubes. All right, I have 3 data sheets here showing our pinouts of the 2 tubes that are used in this design. And as you can see, the only data sheets I can find are for are Chinese and Russian, because those are the 2 countries that manufacture these tubes. Now there are similar ones made in Europe and the States and everything, but they're different, a little bit different. So for instance, this 6F2 has a pentode and a triode, and I showed you that just a minute ago. And this is very similar, almost a drop-in replacement for a 6U8A. So, and you can get a an English or different languages translation of that data sheet, and it'll be very similar to this. I don't think it's identical, but it's close. Anyway, if you look here, here's your 2 filaments, and you notice they're tied together in parallel. And if we follow these little wires, they go to pin 4 and pin 5, just like we looked at. So you can take a look at that. So we were correct. So we were able to identify it by looking at the elements in the tube itself. Now, if we go to the 6P1, 6P1 is a signifier for the version of this tube that's made in China, and 6P1P is the same tube manufactured in Russia. So there are two different signifiers for it, but really it just tells you what country of origin it came from. And they're the same tube with the same properties. People can have arguments over which ones were made where and what quality they are and all that, but that's not what this video is about. So again, if we look, here's our filament, and if you follow pin 4, and then this one, pin 5. So there are 3 different methods of identifying the pin out of a tube if you don't have the data sheet, or if part of it's not marked on the schematic, or I should say, if it's not marked on the schematic. You can use process of elimination, you can use the actual data sheet itself, or you can look at the tube and physically look at where the connections to the elements are. I hope that's helpful. Let's connect it up. Now the first thing we want to make, connection we want to make, is this center tap of our 6.3 volt windings to the chassis ground. And by grounding this, you are actually putting the filaments at ground potential. And what this is going to do is this is going to reduce the possibility for hum. So we're going to make this connection. And we just so happen to have a convenient ground terminal right here next to this black lead, which is the center tap of our filament transformer. So we're going to put that wire on there, but I'm not going to solder it in because we may need to make other ground connections later on in our build. So I'll just connect the wire and leave it wrapped around there. Now, there's different ways to do a grounding scheme in an amplifier. You can have what's called a star ground, which you would have one central ground point, like for instance this lug. Every ground anywhere in the amplifier, all would terminate at that one point. And that can be a good thing in some ways. It can also be a bad thing in some ways, depending on the wire layout and so forth. The other way would be to have a ground bus, where you would have a central ground that's tied again to, like for instance this terminal, and it would be one big thick bare wire that would run across the amplifier, and it would not touch ground anywhere else but right there, and then each ground would tie on to that particular point. That's a bus style ground. The other would be a common chassis ground, which is by far the most common thing, especially on these lower end simple design amplifiers, where the metal chassis becomes the ground plane for the rest of the amplifier. Now that has a lot of advantages because the whole chassis acts as a shield for the whole amplifier when you do it that way. And of course when you do a star ground or a bus ground, it's the same case, because again you're still tying this to the chassis. The name of the game is not to create any ground loops that could cause noise to get on to the ground bus and create noise. In this instance, we're just going to use a common chassis ground. We're not going to worry about it. It's going to work just fine, and you're not going to see any hum. And if there is hum, it's because we did something wrong. We miswired something out of phase, or didn't get a ground securely installed or something. Anyway, let's connect it. Here's another little tip. You don't have to do this if you don't want, but sometimes to keep the wires from fraying, I'll just put a little tiny amount of solder at the very tip, and then when I wrap it around, it'll stay together, and it'll also help this stranded wire push through without spreading apart. You don't have to do that, but in this instance I think it'll help us a little bit. So there you go, that's done. Now what we want to do is we're going to start on the closest tube, and we're going to go to pins 4 and 5, and then we're going to make the rest of our ground wires go from there, and we're just going to daisy chain them together. And what I want to do is I'm going to use solid wire because it's easier to solder on these little terminals, and I'm going to do two things. Number one, I'm going to use two different colors of wire. I'm going to use the yellow and the green, and the reason I'm doing that is I want to keep track of which wire goes where. In other words, if this wire, this specific one, goes to pin 4 on this tube, I also want it to go to pin 4 on all the others. I want to keep it consistent. In other words, I don't want to have pin 4 on this side and have it connected to pin 5 on this tube here, because again, you could get that could induce hum into the circuit. So by using these two different colored wires, and it doesn't matter what colors you use, you can try to follow color codes that people typically use, or you could use your own. The idea is that they're different so that we can always make sure we're getting the right wire on the right terminal. So let me do that. Now I said there were two things that we were going to do. One was to use different colors so that we can always get the correct terminal. The other thing is I'm going to twist these wires very tightly together. And the reason we're going to do that is by twisting the wires, the magnetic fields that are produced, the electromagnetic fields produced on the outside of these wires, they will cancel each other out as they twist around one another. Because as you know, or you may not know, during AC, you'll have one wire the current will be flowing that way, and the other wire the current will be flowing this way, kind of in a loop. So by having those two currents interacting with one another, they'll cancel out. So it just kind of acts like a shield. Now you can sit here and twist those by hand and mess your wrist up, but what I like to do is I will just put this in the chuck of a drill motor, and I will just take a length of it and see very quickly we make up a length of twisted wire. Now I'm going to leave this length of twisted wire all in one piece, and I'm just going to go down the line here, and I'm going to go to pins 4 and 5 and get these two on first. So pin 4 and pin 5, and let me get these through here. And then I'm also going to connect this wire on there, and then we'll solder it. Okay, and I just have these bent up next to one another. And again, we're going to clean our soldering iron tip. And once again, we're going to start by bringing the tip of the iron, I'll bring this in a little closer, you can see. We're going to bring the tip of the iron to our solder joint, and then we're going to put a little tiny bit of solder to let the heat transfer, and then we're going to fill it in. And when we're done, it should look like that. Now I'll do this other one, hopefully around the camera. I'll do it at full speed. That's it. And if you stay on there any longer than that, the heat will start to wick through the actual wire, and it'll start to melt the insulation of the wire, and it'll melt back, and then you'll have bare wire sticking out the back of the socket. So if you go fast like that, and I can't stress enough the importance of having a decent soldering iron. You don't necessarily need a soldering station, but you at least need a good quality iron, hopefully, or preferably that's temperature controlled, and that has very good thermal recovery. What's thermal recovery? Thermal recovery is the amount of time that it takes for this iron. When you apply this to any object, some of the heat is going to transfer from that tip to that object. And that's going to cool this tip down, and it's also not going to heat that up enough. So this has to transfer the extra heat to heat itself back up while it's heating up the joint that you're trying to make as well. And that's called thermal recovery. How fast it can replace that missing heat is the thermal recovery. Now, you don't have to have a really expensive iron to do that. There are little soldering stations, and there's actually pencil types that just plug straight into the mains that are that either have very good thermal recovery because they're big, they don't, they have big heating elements, or they have the built-in circuitry right in the handle to get the heat that you need. But that is a good investment to buy a decent soldering iron that has a decent quality tip and has good thermal recovery. That's the difference between the cheap 30-watt pencil that you buy that takes forever to heat up when you plug it in, and one that costs a little bit more but performs a lot better. Now, moving along here, we want to keep our wires close to the chassis. We don't want them up. Even though they're twisted, they still can emit a little bit of noise. So we want to keep it as close to that ground plane as we can. So what we're going to do is we're going to run this along the front here. I'm then going to bend it up and go like this, and then I'm going to cut it part way out. And then what I'm going to do is I'll untwist a little bit of it where it's going to connect to pins 4 and 5, just like that. And I'm going to untwist the other end that I cut, because of course this is going to continue through. And I'll get these both in here, and remember, I'll keep the colors the same. So the green is on pin 4, so I'm going to make sure that the green lead goes onto pin 4 over here as well. So it'll be just like that. And then I'll add the green on this side. And I'm going to go all the way around like that. So I'll get this one put together so you could see it, we'll solder it, and then I'll finish the rest off camera. Okay, here we go again. Always clean our tip off a little bit. There we go. And then we just snip off our excess. All right. And we're good to go. So then we're going to just continue. We're going to bend this one over, keep it tight, do the same thing, and we're going to go all the way around like that. And here we are. Here's the finished product. Just try to keep it neat. Try to keep it close to the chassis. And if you remember those few little tips when you're wiring your filament string, it'll work out really well for you. Okay, we have our power cord connected, and let's see if we have our 6.3 volts on pins 4 and 5 of each of the sockets. So here we go. Got it there. And notice this is kind of high, and that's okay. Wait a minute, 1, 2, 3. Oh, I'm sorry, 1, 2, 3. There's 4 and 5. 4 and 5. 4 and 5. 4 and 5. And again, there's no load on this right now, so it's going to read a little bit high. But as soon as we connect the tubes, which we're going to do next, that voltage should drop to a reasonable level. And putting in our tubes, we can see they all light up. Our filaments are good, our wiring is good, our sockets are good. And I'll just show you real quick what the voltage looks like now. Okay, we now have full power on this, and I have the tubes fitted, and when we turn this on, you can see with a full load you have about 6.5 volts. It's a little bit high. And then once you put the load on the high voltage windings, that'll drop even a little bit more, and it'll be right around that 6.3 volts that it needs to be at. And that's it. So there's the wiring of the filaments and the filament winding of your transformer. Alright, I have some busy work coming up in the next few days, so I don't know when I get the next chance to do the video on the diode section and the power supply build, but I will try to get to it as soon as I can. Until then, I wish you all peace, joy, happiness, good health, and my clothes dryer buzzing. And I wish you all well. Take care and have a great day, everybody. Bye-bye.